C.
All right, good. You put the right one.
Compressing the vapor, A. Increase the pressure and decrease the temperature.
Compressing a vapor. What happens when you compress a vapor? Obviously, the pressure is gonna increase, right?
Yeah.
It's also gonna get hot.
So both should.
Increases pressure and temperature.
Yeah. D.
Yeah, D, yep.
Oh, is it me?
It is you.
Technician A says that any technician that handles automotive refrigerant must be certified in knowledge of regulations by an EPA-approved agency. Technician B says that recycling equipment must be properly approved. Who is correct? I don't recall Technician B in the book, but I said both because Technician B sounds right, but I know A is definitely right.
Okay, yeah, it's both of them.
Okay.
Yeah.
A main source of heat used to warm the passenger component is D.
Is the engine, yep, it is. Any source of heat from your heater is your engine.
Number
Okay.
10. Technician A says that heat is measured in degrees. Technician B says that temperature is measured in degrees. Which technician is correct? B.
It is B, yes. Heat is not mentioned in degrees, temperature is. All right, let's
Bless you. Yeah, E.
see, where are we at? E.
True or false?
Yeah, we did that one, right? Okay, we did one, right?
Yes.
Which component is heat added to the refrigerant?
Heat added to the refrigerant.
And what, and which component is he added?
Is C.
The condenser.
No.
Evaporate.
Evaporator, yeah.
Oh.
Okay, we did three. Which of these is not a subsystem in a modern HVAC system?
D.
All of
D?
them. All of them are correct.
Yep, because they are all subsystems. All right. Which type of refrigerant hose is used? With an R134A
B?
system, I don't know if we talked about that, it's called a barrier
Barrier.
hose.
Oh, very.
This is probably gonna be on your regular test, so remember that.
Very.
We did the compressing of vapor. If the evaporator is damaged, it must be replaced. This is just common sense with a new one. Okay? We did that one, we did that one, and compressor operates continuously in what type of system?
POA, D?
Well, it's B and C actually.
DNC, I'm fine.
Yeah, okay. Obviously, if orifice tube, no, because it cycles, compressor cycles, so this says continuously. So you can just eliminate this one and call it good, right? Okay. All right, all right, all right. We're going to do 64. If you're gonna disappear, then they'll see you tomorrow.
See you tomorrow.
Hopefully you're gonna be in better shape for us tomorrow.
I'm sure I will.
Right. Okay. Air management systems. What the heck is air management?
Managing air.
Exactly. How does the air get where it's going? know how to control the dials in your car, right? Where do you want the air to come out? You want it to come out and blow on the windshield, you want it to blow on your face, you want it to blow on your feet? What do you want it to do? You want it hot, you want it cold? I'm gonna talk about how that works. Different components in that air management system: airflow control, temperature control in the AC system, filtration, obviously cabin filter, the air ducts that get it where it's going, control doors, the plenum is the big unit inside the car, non-electrical and electronic HVAC controls. Okay. The system that contains your HVAC plenum ducts and air doors is called the air management system. Airflow is controlled by 3 or more doors, which are called flap doors sometimes. These are just doors that open and close to direct air in different positions, okay? If you decide you want the air to blow out on your feet, because that's normally the way it is when you turn your heater on. When you turn your heater on, unless you direct the air somewhere else, it's gonna come out of the floor, right? And blow on your feet. Heat rises, right? So if you want it on the bottom, it's gonna end up at the top anyway, right? Air inlet doors are used to select outside or inside air inlet. The temperature blend door is used to adjust the temperature. The temperature blend door is the one that's got the red and the green on it when you turn the little dial there, right? Okay? Or the red and blue, I should say. Normally red and blue. Okay? And the mode door, that is the one that's used to select the discharge location, meaning is the air going to come out, blow on the windshield, floor, blow in your face, whatever, okay? These are the components that the system uses to provide that airflow, fresh air or recirculated air. You notice on your AC controls, you'll have the thing that says recirc or fresh air or something like that. That just means, is it bringing air from the outside, or is it recirculating the air that's already in the car? Yeah.
Isn't it when you have the AC on, you're supposed to do the recirculation and heat? Like no recirculation?
Normally on max AC setting, it just recirculates. Just automatically goes to recirculate instead of fresh air. Yeah.
And then with heat?
The heat?
Yeah.
If you turn your heater on, normally you're getting your air doors open and bringing air in from the outside. But it depends. You can select it any way you want it. But when you turn the heater on, it's going to naturally, unless you redirect, it's going to blow air on, off the vents toward your feet.
So what causes like windows to fog up?
Depends. You mean after you turn it on?
Yeah, so like say you have it on and you have like the heat or recirculation.
Okay. Here's the deal. Normally, if you have your heater on and you're trying to like defrost a windshield or something like that, the AC compressor will come on. And what it does is it takes the moisture out of the air in order to, so it doesn't fog the windshield up, and it will clear it instead of making it worse. So normally that's what's going to happen. If you shut it off, which you can manually with the little snowflake button, then you may have a problem with the window or fogging up. But the other instance would be, let's say you had a heater core that was leaking, then it would definitely fog up the windshield like really bad. So to the point where you probably couldn't even drive the car. Okay, your fresh air or recirculation door is for your air conditioning, defrost, and heat. Control head, that's just your controller, connects to various parts through electrical, sometimes vacuum connections. Older cars, mechanical cables, or a combination of all of these. Okay, airflow is directed toward the windshield, dash, or floor vents, or combination, depending on the system settings. Sometimes those dash vents are called registers. Okay, these guys here, everybody's familiar with your vents where your air comes out, right? Defrost, gonna blow out on the windshield. Floor heater vents for your heater. All that air gets redirected based on what you tell it to do. Open and closing doors. That's all it does, okay? If you take it and you say, I want the temperature to be nice and hot in the car, and you turn it all the way to the red, it's going to close one door, open another, and make sure that the air goes past the heater core, gives you hot air in the car. and directs it wherever you want through the mode door. This is how those major sections of that work. You have air inlet, plenum, and air distribution. The shaded part shows the path of the control doors. So this shaded area here, here, and here just shows you the path of this door. Just moves from here to here, here to here, whatever, okay? Temperature blend door, recirculation, and the air distribution section there. Sometimes those don't make a lot of sense by looking at them, but in the defog or defrost mode position, the air is directed through the evaporator to remove the moisture from the air before being sent to the heater core. This is what keeps your windshield from fogging up. Goes through the evaporator first, removes the moisture, then it goes through the heater core, warms the air, then it sends it to the windshield. Okay, most control heads include a control for turning the unit on, setting the mode of operation, controls for temperature, control of the fan speed. And most cars have a little snowflake button here that just turns the compressor on. Okay, you can manually turn this on or off anytime you want. You can have your setting all the way on cold, fan all the way up, have this blowing on your face, and the air conditioner not be on. This snowflake button has to be lit up. There's a little LED right here. It tells you if it's on or off, right? So if it's not blowing cold and you got all the settings where it should be, make sure that that snowflake button is in or the compressor won't work and you won't have cold air, okay?
A lot of them need that button to be like highlighted. I'm saying that very seriously because they come in with that, my AC's not working. Did you push the button?
I've seen that. People bring their car and they got an AC problem. Okay, got the fan all the way turned up. I got it all the way on cold. I got it blowing out on my face. The air's not cold. Well, you gotta push the snowflake button. A lot of times it comes on by itself, but if it doesn't, hit the button. If that little light isn't on, the compressor won't come on and you will not get cold air.
By the service area at Chevy,
Yeah?
in the summertime, it's just packed. It's just like you see cars lining up from the street all the way.
Yep.
Either they have a problem with the AC or the AC tubing, something like this broke off or leaking. This is a bunch of cars coming in.
You will notice as you go through this class, because we're gonna roll into summertime before this class is over, the shops get really, really busy when the temperature goes up. As soon as it hits about 85, 90 degrees, they get busy. Cars do not like heat. Things break. People realize, oh my gosh, my air conditioner doesn't work, or whatever.
Cars get more accustomed to heat, like say, you live in Vegas.
Mhm.
Say you like live in like California, and your car's used to that weather, and you come to Vegas.
Yeah,
Like,
so sometimes it's not a big adjustment, but sometimes it is. But yeah, because cars kind of get used to one thing or the other, but heat is hard on cars. So we had a lot of, the shops are really busy in the summertime around here, really busy. Okay, we just talked about this. What does the snowflake button do? It just turns the compressor on or off if you so desire. Could look like that depending on your car. Okay, what are your three main HVAC doors?
There's mode,
That's one of them.
air inlet,
Okay,
temperature.
air door,
Yeah, temperature blend door.
and the temperature blend door, yep. All that one does is, you know, you got your blue and your red, right? Anywhere you put it in there, it's going to mix a combination of cold, hot and cold air, whatever it takes to make it just cool in the car, warm, hot, whatever you want. It's done through this temperature blend door. So what happens with this is, it doesn't just go all the way one way or all the way the other way, unless you go all the way hot or all the way cold. So if you go in the middle, that door is going to be somewhere in the middle. So it's going to let a little bit of cool, a little bit of warm or hot to make the air warm or whatever temperature you want it. Okay. Airflow, operation, how much volume of HVAC air is controlled by blower speed? Types of doors, different types, there's rotary, there's sliding, there's flap doors. This is just giving you an idea of that not all the air doors work the same, but this is not something you gotta worry too much about, but might wanna remember that some of these do move certain ways and degrees. Flap door, 45 to 90 degrees, rotary door, could go 100 degrees. And some of them have a sliding or rolling door in them, but many of them slide on their upper and lower pivots shown in red. Nothing exciting there, it just shows you how the door moves. This is a type with a rolling or sliding door, almost fully closed in this particular picture. Same one, half open. All right, air temperature control. Temperature control using airflow. Air is heated or cooled as it passes through the evaporator and heater core. Temperature control using a variable compressor. Remember the variable compressor? There was a positive displacement and variable. The compressor will displace, it's adjusted to cool the evaporator just enough to cool the air to the desired temperature. Okay, this is a whole bunch of arrows showing where air goes in certain modes of operation. The blower motor is what forces the air through, and then it takes the path of whatever doors are open or closed. But the blower motor will force the air through the AC evaporator to remove the moisture before it is sent to the heater core. So as I mentioned before, if you turn the defrost on and it's in the heat mode, normally turn the compressor on, get rid of the moisture so it doesn't fog the windshield up. Filtration is done through a cabin filter, which everybody should be familiar with. Most systems have a cabin filter, not all of them. Some older cars don't have cabin filters, okay? They just decided that that was a good idea maybe, I don't know, 20 years ago. Filter is also called an HVAC filter, interior ventilation filter, micron particulate filter, or pollen filter. This is one that hasn't been changed in a long time. Extremely dirty cabin filter. If you find that the air doesn't come out of the vents very hard, even when you got the blower on high speed, that's probably what's wrong. Okay, cases and ducts. Evaporator and heater housing is molded from reinforced plastic, contains your evaporator, heater core, blower motor, and the air control doors. Housing is called a plenum, connected to inlets and outlets using formed plastic. That's an actual picture of one. Typically, you would have to remove that whole HVAC housing in order to service the evaporator core, or the heater core. Blower motor, not necessarily. Since a blower motor is something that could be considered a periodic replacement item, they don't want you to have to tear the whole car apart to replace a blower motor. So normally the blower motor is pretty easy to change. You can usually do a blower motor in under 30 minutes. They don't vary that, although it's in that case. They make it accessible. Okay, your air inlet to your HVAC system can be at the base of the windshield, usually covered with a plastic screen. I'm sure everybody's seen those. That's where leaves and stuff like that like to gather. It end up in your cabin filter.
That's how you can get, that's how the air comes from, right?
Mm-hmm.
From your
Yep,
cabin filter.
that's how the air gets in for your.
That's why if you don't press that circulate button, it's just gonna, all the air is just gonna go through that vent in your car.
If you don't do what?
If you don't press the circulation button. that's
Oh, the
all
restart button?
Yeah.
Right, then the air comes in through there, right? Right.
I saw this video of a guy cleaning it, he said just like on your AC into the max, turn off the circulation button,
Mhm.
you spray some type of freshener in it to make your things smell good.
Oh, yeah,
Sprays
yeah.
it and freshes up your whole car.
Yeah, you can do that, yep, yep.
That's another way.
I've seen people spray the cabin filter with Febreze or something like that before they put them in, and makes the car smell good. That's fine, you can do that.
I use it for the air freshener, you just put on the clip. And
Oh, yeah. Yeah, yep, you can do that too. All right. Your air inlet door, fresh air door, recirc door, outside air door. These are just all names for this. They're all the same thing. Again, for some reason, just not every manufacturer calls it the same thing, but it is all the same thing. Okay, the air inlet door could be called any of those. Can be positioned to allow fresh air to enter while shutting off the recirculation opening. It could have air to return to the recirculate from the inside of the vehicle while shutting off the fresh air, or a mix of both. Your temperature blend door, all that does is control the interior temperature based on whether you have it in the green or the red position or somewhere in between. I'm sorry, blue. I keep saying green, huh?
Yep.
It's blue. You know that. I'm thinking of traffic lights, I guess. Okay. Blue or red. Some other names for that temperature blend door are air mix door, temp door, blend door, diverter door, bypass door. The last two you won't see too much of. 90% of the time, it's going to be called one of these. Temperature blend door, air mix door, something like that. If your car has separate driver-passenger temperature controls, you've seen those, right? Cars have separate controls for driver-passenger temperature. It's going to have two of these. Okay? These are all the same thing, they're just different names, so these aren't different things, okay? This is all one door, temperature blend door. It's just what some people call it, or manufacturers call it. Okay, and if you have separate driver-passenger temperature controls, it's going to have two of those. Air distribution outlets. Air from the plenum flow to one or two or three of the outlet paths. Your registers, meaning your vents that blow right in your face. The defrost blows the base of the windshield, heater at the floor. Airflow to these ducts is controlled by one or more mode doors. Mode means where do you want it to come out, okay? Mode or function control sets the door as follows. If you turn it to AC, it will automatically blow out the dash registers. Max AC, same place, only it will go into recirc. Heat, floor level with outside air. Max heat, floor level with recirculated air. If you put it on bi-level, you will get both dash and floor discharge. Put it on defrost, comes out the windshield registers. So where you set that shows you right there what happens where the air comes out. As I mentioned a minute ago, the dual zone air distribution system will allow the driver and passenger to select different temperature settings, and it will have two air temperature blend doors. Okay, this is just showing you how the air goes across the heater core and then down to the floor.
They can have three actuators?
I'm sorry.
They can have three actuators?
Okay,
HVAC?
we haven't got to that yet. However, these doors that we've been talking about, what moves them? They don't move by themselves, they're not magic, right?
No, it's.
Something has to move those doors. Those are called actuators. They're little electronic things that will, motors that will move the door wherever you select it to move, okay? So it takes actuators to move those doors, whether it's an air door, a blend door, a mode door, whatever it is. We'll get to the actuators in a minute. In the blend system, all of the air is cooled, some of it's reheated, blended with the cool air to get to the right temperature. This is called a reheat system. In the reheat system, all of the air is cooled and reheated to the correct temperature. By the way, there's going to be a question on the test that says, what is a reheat system? You might want to remember that. And if you miss it, it's not my fault.
But why does it do that?
Why does it do that? In a reheat system, all the air is cooled and reheated to the correct temperature. It's going to be cooled first to remove the moisture from the air and then heat it to keep the windows from fogging up. Ducts are placed in the center.
It's coming straight from the evaporator. Okay.
Cool, because it has to go through the evaporator core in order to be cooled, so that's where all the moisture is removed as well.
Okay.
Okay. Ducts are placed in the center console, on the floor, or the front seats provide heated and cooled seats. Some cars have heated and cooled seats. Obviously, all they do is they just run extra ducts to the seats.
You can feel the fan on the cool seat.
Uh-huh.
And it's pretty loud too.
Yeah, yeah. You won't see this anymore, but early cars, before electronics and all that cool stuff, things were just primitive. They were cable operated. There was no little dial to switch from hot to cold. It actually had a slide. And when you would slide it from hot to cold, it actually pulled a cable. And that cable moved the door.
Wait a minute, say that again?
Huh?
Say that again?
Okay. In the dinosaur cars, before electronics and all that stuff, if you were to change the temperature in the car with a little slide control from cold to hot, right? You had this little slide control.
Yeah.
You just slide it from one way to the other. It was actually hooked to a cable, and that cable was just hooked to the door, and as you moved it, it moved the door. It was cable operated. Yep.
Don't they have that a lot in Chevy?
Well, the older cars, they were all like that, but some of them may still use cable for some stuff, but for the most part, they've eliminated that. And then they went to vacuum operated systems that seemed to work a little bit better, and now they're all electronic through actuators. But they may still have some vacuum operated systems in them. Many will use vacuum actuators, sometimes called vacuum motors, to operate the air inlet and mode doors. Controlled by a vacuum valve that's controlled by the control head. With no vacuum signal, this just shows you how one of those works. Spring extends to the actuator shaft, place the door in a certain position. Vacuum signal pulls it the other way or the other position. And on those types of systems, just so you know, sometimes they would have a problem. Maybe the vacuum line would crack or break or rot or whatever. When you go to turn your AC on or your heater on and it blows air out the windshield, on the windshield, and you can't get it to change modes, that's the problem. You got a vacuum problem. In fact, I think there's a little check tip in there or something like that where it says something about air blowing on the windshield all the time. Check for vacuum to the actuator that probably broke. As you see here, many older vehicles use vacuum actuators to move the doors. When the vacuum actuators operate, they alter the air-fuel mixture of the engine because the vacuum control affects engine operation. This is just really ridiculous if you ask me. Yeah, it might affect it a little bit, but not enough to matter. I'm surprised they even brought that up. Okay, this is what you're going to see. Electronic Most recent vehicles use electronic function switches at the control head. This system uses electric actuators or motors to operate the air distribution temperature blend doors. There is a 2-wire, a 3-wire, and a 5-wire, which you will see on one of these pages here. 777. Yeah, see where it says tech tip, defrost all the time, check the vacuum. So if the air blows out the windshield all the time, no matter where you put it, you may have a vacuum operated system with a vacuum problem. Okay. Your 2-wire actuator. This is a typical actuator that rotates when electrical impulses are sent to the brushes of the motor, just like any 2-wire motor would work. A 3-wire is going to have a power, ground, and an input signal wire from the HVAC control module. As you know, everything has a control module on it, right? Some cars can have 10, 15 computers on them. Control module for everything. A lot of cars, well, almost all new cars have HVAC controllers. The 5-wire is going to have 2 wires to power the motor, power and ground, and a 3-wire potentiometer that's used in the HVAC control module for the motor's location. What does that mean? It means it has a feedback circuit. So, let me give you an example. You turn your air conditioner on, you turn it all the way to cold, you turn that fan on high, and that actuator is supposed to move that blend door all the way to the cold position so you get nothing but cold air. Okay. Just because you put it there doesn't mean it goes there. Now on these other systems, you had to just trust that it went there because there was nobody monitoring it, let's say. There was nobody spying on it. Okay, you want this all the way cold? Let's see, did you go there or were you not going there? This has a feedback circuit in it that tells it, did it go there? And if it doesn't, it will actually set a trouble code in the body control module. It will say, your mode door or your temperature blend door actuator did not go where you put it. It's going to see the signal from the control head, and then it's going to say, okay, did it go there? And if it didn't, it's going to tell on it.
What code would that be?
What's that?
What code would that be?
It depends on the car and which actuator it is.
Okay.
But they're going to be typically a B code, which is body controller. Okay? C is for chassis, P is for powertrain. The codes are all structured to where you know what each one is, as far as what system it's related to.
Right.
Okay. The HVAC actuator may need to be calibrated after it's replaced. If it does, it's typically a simple procedure. Sometimes that can be done with a scan tool. Sometimes you can just turn the ignition on and off a couple times. It'll recalibrate itself. Okay. These are actually what some of those actuators look like. There's 3 of them right here. Sometimes these are easy to get to, sometimes they're not. For the most part, like your blend door actuator and stuff like that, sometimes you can get to those fairly easy. Sometimes they're a little bit of work to change. Depends on the car. But that's what they look like. Typically we'll have 2 or 3 little screws in them and 1 locator pin just to get it in the right position. I will tell you this, don't plug one of these in and try to see if it works without it being connected to the HVAC system there, because it will over center itself, go through far, and it'll mess up the actuator. So don't plug it in and just see if it works, okay, with it not installed. Okay, now we're going to get through a couple of schematics to show how those controllers work. This is a basic 2-wire. All it takes to make a motor work is 2 wires, right? Power and ground. And what happens if you want it to go the other way? You just reverse the power and the ground. You reverse the polarity, right? So here's your actuator, 2-wire motor, right? 1 wire here, right? Okay, here's your controller. If you want the motor to go one way, you switch it here, you have power here, you have 12 volts here. If you want it to turn the other way, they just switch it, and it switches to polarity, the motor runs the other way. It's the way your windows work too, right? Push the switch one way, your window goes down, you push it the other way, the window goes up, right? All you're doing is reversing the polarity on the motor, make it turn the opposite direction. That's what your window switch does, just like that. Okay, now it's going to get a little more complicated. This is a 3-wire, it's going to have a logic chip inside of it. Sends a 0 to 5 volt signal to the motor assembly to control the direction of rotation. And then the 5-wire. This is 2 wires for power and ground, which you got to have no matter what. 3-wire potentiometer or the position of it. That's your feedback circuit. Tells the controller, did that actuator actually move that door where I wanted it? Okay, this is a typo. This should say, what is the purpose of the 3rd wire used by a 3-wire actuator? Why is it asking about the 3rd wire? Because you know that 2 of them are power and ground for the motor. What does the 3rd wire do on a 3-position actuator? You might look at page 777. What does it do?
It says a typical 3-wire actuator uses a power ground and an input signal. So the 3rd one is for an input signal.
Okay, signal from the control module. Okay. Okay.
Now I also see here that it says if the motor receives a 2.5 volt signal, the motor stops rotating. So where would it receive that? Where would it receive that signal from? I'm not understanding why it says.
Okay,
that.
so when you select something with the control head, right, on the dash that you operate, it sends a signal to the controller. Okay, what do you want to do? And then the controller says, okay, this is what you're going to do. The controller's the middleman.
Right.
Okay? That signal comes from where you select it. It produces a certain voltage, and then it sends that to the actuator to tell it to go whatever position it wants it to go. Yeah?
Yeah.
Okay.
So how?
Go ahead. Sorry. What happened with the white, the 2-wire? That has that doesn't have the middle wire. How
Right,
does
it doesn't have a 3rd wire, doesn't have a 4th or a 5th, doesn't have a potentiometer, doesn't have a logic circuit, doesn't have a feedback, nothing like that.
Okay.
It works just like a window, okay? So let's say it's a blend door and it's just a 2-wire. You got hot or you got cold, okay, or somewhere in between, but all it does is reverses the polarity and make it go one way and then the other way. Okay, again, just like your window going up and down. Okay, you could think of your up as your hot and down as your cold or whatever, but it works the same way. Okay, it only takes 2 wires to operate a motor, and if you switch the polarity on them, meaning positive and negative, switch them, motor just turns the other way. Your blower motor moves the air inside the vehicle. It's a permanent magnet motor. It gets its power from battery and a ground through a variable resistor to control the speed. The variable speed control is achieved through a fixed resistor pack or electronically controlled module. Diagnosis of the blower motor. If it does not operate at any speed, meaning you got no blower at all, no speed at all, you have a bad ground wire, a bad power wire, a bad motor itself. And in the power circuit, obviously that can include a fuse, wiring, something like that. If the blower motor works on low speed but not on high, usually an inline fuse or high-speed relay. Squirrel cage blower motor, replacement blower motor usually does not come equipped with this guy right here that they call the squirrel cage. You will have to take that off, put it on the new motor. Just got one little nut right here in the center of it. It's an easy switch. Okay. When we get into the electronics section of the class, you'll see a whole bunch of this. Whole bunch of schematics. This is a basic blower motor circuit with 4 speeds, controlled through fixed resistors. The 3 lowest span speeds, low, medium-low, and medium-high, use the blower motor resistors to drop the voltage to the motor, reduce the current to the motor, and slow it down. Okay. So how does this work? You ready?
Not really, but go ahead.
Okay. I'm going to show you how this works. Okay? Everybody ready? Okay. Here's your battery, right? This is where you start at. Okay. This battery post is grounded, which means the system is grounded. Okay? Everybody's happy there. Here's your power. Here's your ignition switch. What's happening in this circuit right now? Absolutely nothing. The ignition switch is open. That means you haven't turned the ignition on. So nothing happens, right? Okay. You turn the ignition on, okay. Now we got power flowing. And if the fuse is good, you got power here, right? Let's say you want the blower motor on low. Here's your low speed, right? It's going to go through this wire, through this resistor, through this resistor, through this resistor, and it's going to feed the power to the motor. The motor's already grounded. That's all it takes to make the motor run is power to ground, right? But because it went through these 3 resistors, you only got a little bit of voltage, a little bit of current to the motor. So it's only going slow because you selected low, right? Make sense? Okay. Now we want to crank it up a little bit. Let's say that's not enough and you go to the next span speed. Okay? Now it goes through this resistor and this resistor to the motor. Motor speeds up a little bit, right?
Oh, I see.
Because it's only going through 2 resistors. Resistors will reduce current flow and voltage, okay?
I see.
So now the motor turns a little faster, right? Right. Okay. You decide that's not enough. You go, I want to turn it up to the next speed. Now it just goes through this resistor and into the motor. So it speeds up again, right? Should be. That's pretty basic, right? Until you turn it on high. Turn it on high, what happens? It bypasses this whole thing here. Goes straight to a high blower relay. And what happens when you send power? It's right here. Energizes this relay coil, closes the contact on here, and now all of a sudden you have a full 12 volts to that motor, and it whizzes, blows your hair back, right?
Why? Why does that have to go through a relay? Why does that have to go through a relay?
I can't.
Why can't it just go to the motor? Why does it have to go through a relay? Why does there have to be a relay there? Am I overanalyzing it again?
There absolutely has to be a relay there. If this was just hardwired to here, these wires would overheat and melt. This absorbs the current here. So a relay is just an electromagnetic switch, okay? So what happens here is, we got a whole bunch of them eventually.
This is the higher voltage,
Right.
the higher,
Right, right.
Okay.
Right, because you got full amperage and current voltage to this.
Yeah.
So what's going to happen is it's going to overheat something, probably the wiring.
Yeah, basic electrical system.
Mhm,
I
mhm.
got a brain fog, I forgot, okay.
So, this is important because you're gonna be asked test questions like this throughout the ASE and stuff like that. It's going to have say something like, your fan only works on high. You select this speed, this speed, this speed, nothing happens. But you turn it on high and all of a sudden it works. What's wrong with it?
The relays.
The blower motor resistor pack, this
Or
is
the
usually one
resistor.
piece. Has all the resistors in one resistor pack, okay? Now, you have another scenario where it works here, it works here, it works here, but when I turn it on high, it just shuts off, nothing happens. I got no high blower speed. Then you got a problem with the fusible link here or the relay.
So, if it's low, it's one of the resistors, but if it's high, then it's the link or the relay. So if it's low, there's no way it could be the link? Even if it's on low? There's no way that it could be the link? Because if it's on low, it goes directly to the motor. So then the link doesn't have anything to do with it. Well, it does, but it doesn't. Is that right?
Okay. If you had this fusible link and this fuse works all of these other fan speeds.
Right.
Okay? As you can see, this is connected here all the time, but it doesn't do anything because this is open. The only way to feed this power is to feed power to the relay coil wire here. This produces an electromagnetic force that closes this contact.
Oh, so that fusible link, okay, so that's why.
This
if
is
it's
the
on
this
low,
is the
fusible
same thing
link-
as a fuse. It's
Yeah.
just a wire.
But that
Whereas a
ain't-
fuse is actually a fuse. A
Okay,
fusible link, if it goes bad, it just melts a wire in half. It's a special wire that's designed to melt if the current flow is too high.
right, right. No, I'm looking at it to where if it's on, if the resistors go out, then would the link go out too, but it
No.
won't, because the link is only has to do with the high speed and not the lower speed.
Mhm.
Okay,
So if you only had high speed, the first thing you would do is check, make sure this fuse is good.
mhm,
And then, at that point, most likely that resistor block is bad. Okay, we'll pick this up after lunch. Let's just go break for lunch now before we get any deeper into this. So I'll see you back at 12.